So now we'll talk about grading test. Now grading means what? How the particles are distributed, right, over a given seed size set. Because the aggregates, whenever you see any particular mix, let's say talk about bituminous concrete, right? Talk about bituminous concrete, or talk about dense bituminous macadam, or pavement quality concrete, or dilute concrete, or wet mix macadam. So all these particular layers have particular grading. Now grading means the aggregates should be distributed over a given set of sieve with some percent rated or some percent passing, so that they form a very well defined gradation for this particular layer. So to identify this grading, it is first important to know what aggregate size we'll be using. Now in the plant mix, what happens in a particular given site, we won't produce a bituminous concrete grading particular for it. Similarly, for a DBM grading, we won't produce a particular grading from the plant. So what we will do, we will try to mix some different aggregates, right, and then develop grading for DBM. Similarly, we mix different aggregates and develop grading for PQC. So normally what we do in the site, we will be having different stockpiles. We will produce different stockpiles like 40 mm down size, right, and 20 mm down size, and then let's say 10 mm down size, and then it can be crushed dust. So basically what we have done, we have produced aggregates which are 40 mm passing, but we don't know what is the relative grading of the particular aggregates. Similarly, we produced aggregates which are having size 20 mm and lower. Similarly, we produced aggregates 10 mm and lower. Similarly, we have crushed dust which is passing through fine aggregate, fine seed. So now we need to find the aggregate of each particular stockpile, so that when we mix them in a particular proportion, right, we achieve a grading what we wanted. Basically, it can be a WMM gradation, or a PQC gradation, or a DLC gradation, or a bituminous concrete gradation. So now, if you want to go for a final grading, normally we won't use this 40 mm seed. Let's say for a bituminous concrete, we don't need a 40 mm seed, but for pavement quality concrete, for a PQC concrete, we will need 40 mm aggregate down size. So basically, we will this is a set of ISCs for a given layer. Now this numbers of this sieve set may differ from mixer to mixer. That means for a bituminous concrete, it can be having different sieve set. For dense bituminous macadam, it can be having different sieve set. Or for PQC, it can be having different sieve set. So now if you see, for a given mix, it can be bituminous mix or a concrete mix. So we have particular sieve set, a defined sieve set, which we will arrange in the decreasing order, right? There is 45, 22.4, 11.2, 5.6, 2.8, 1.4, like that we will arrange in decreasing order. And the bottom is called the pan, which is a collect all the dust particles at the end. So now basically what we will do, we will arrange in this order. Then we will put each aggregate stockpile. It can be 40 mm, we will place approximately around 15 kg. Similarly, for 20 mm, first we will see this 40 mm and get some particular weight, which I will tell you. Then we have again, let's say we take around 10 kg for 20 mm. For 10 mm, we will take around 10 kg. And for crushed dust, let's say we will take around 5 kg. So we will see them, these aggregate stockpiles or aggregate sizes individually, and determine the grading of 40 mm, determine the grading of 20 mm, determine the grading of 10, and determine grading of crushed dust. So we will take a typical 40 mm grading now. Let's say we will find the 40 mm grading, and this is sieve set. So we will take 40 mm. This is 40 mm grading. So now we will put a 15 kg of materials and pass through this all the sieves. So what happens? Some aggregate will pass through 40 mm and some will be retained on 22.4. Similarly, some will pass through 22.4 and retained on 11.2. Similarly, some will pass through 5.6 and retained on 2.8 mm aggregate sieve size. So now we will note them known as retained mass. Retained mass. right? So we will note each values as a retained mass, whatever, that means 40 mm passing and 20 mm 24 retained, we get one particular mass here. Similarly, 22 passing, 11.2 retained, we get one particular mass. Similarly, 11.2 passing, 5.26 retained, we get a particular mass. After this, what you will do is determine percent retained. Percent, because already you know the mass, you will divide by total mass. If this is, let's say, this is x, this is y, and this is z, so percent will be x by 15 into 100. Similarly, it is this then this will be y by 15 into 100. So this will be z by 15 into 100. This way you will find the percent retention. Then what you will do? Determine cumulative retention. Cumulative retention. Because you will start adding. So this is, let's say, assume this is 0. This will be again 0. This will be 0 plus x. So this will be 0 plus x plus y. This will be 0 plus x plus y plus z. This will determine the cumulative percent retained, and then what you will do? You will find cumulative percent passing. This is retained, you find cumulative passing. Now to find if this is 0 is retained, then passing is 100, right? And in this, what's happening here? X percent is being retained, passing will be 100 minus x. Similarly, in this, passing will be 100 minus x minus y. This way you will find the percent passing, and this is the grading what we will develop for the 40 mm aggregates. We will do in similar manner for 20 and 10 on custom test. This way you will determine the grading for each aggregate stockpile and find the grading for a given mix using a method called blending method. Blending method.